All right, we're in section 2.2, and here we're dealing with the domain and range for each relation. So we have a relation here between the first coordinates and the second coordinates, and then we need to state whether the relation is a function. So that's the next step, is determining if the relationship is a function. So keep in mind in the slide, I define the domain and range for ordered pairs. And it mentions that the domain of a function or a relation is the set of all first coordinates of the ordered pairs. So this specific definition really helps with when you're dealing with ordered pairs like this. We'll get into functions, more defined functions, where we have more ordered pairs later, and we'll figure out how we can express that, but we'll get into that later. And then the range of a function or relation is the set of all second coordinates of the ordered pairs. So just so we know what an ordered pair is, which was discussed earlier in the term, ordered pairs in chapter P, but just to review, ordered pairs is in the form x comma y. So this is an ordered pair. So we have in this first problem, we have 1, 2, 3, 4 ordered pairs. And as mentioned, for domain and range, the domain is the set of all first coordinates. So this is the first coordinate, and then the range is made up of the set of all second coordinates. Okay, so we have 4 first coordinates, and then we have 4 second coordinates. So the domain of this first problem would be the set of all the first coordinates. 2, 5, -4, and 7. And then the range would be the set of all the second coordinates. So 3, 1, 3, and 11. And so what we don't really need to count the 11 twice. So we can just cross out one of the 3's. We don't need to repeat it twice. But this then goes into what a function is. So a function is defined up here. So we need to now determine if this relationship that's defined in question 1 is a function. So is the relationship a function? That's going into the definition of the function. A function is the set of ordered pairs in which no 2 ordered pairs have the same first coordinate and different second coordinates. So notice that, okay, so if we have the same so we really can't have the same first coordinates. If we do, we have to have the same second coordinate to be a function. But if we have the same first coordinates and different second coordinates, then we're in trouble. But as we can see, we have all different first coordinates. So that's all good. So this is a function. So it is a function, yes. All right, now going into the second problem. So the second problem, the domain is the set of all, excuse me, all first coordinates. So that's 5, 3, 4, and 5. All right, you may be noticing something. We have repeating first coordinates. That may be an issue when we get into a function. Okay, so when we're talking about the domain, we don't have to repeat values, similar to range, how we crossed out that 3. Okay, and now we are going into range. and we have 10, -2, 7, and 8. The closing bracket. Okay. All right. So now we're into, is it a function or not a function? Notice, okay, again, looking at this definition, no two ordered pairs have the same first coordinate. We have the same first coordinate and different second coordinates. Notice that they have different second coordinates. Bad. So if we have the same first coordinates, we have an issue if they're different second coordinates. So the idea of this with a function can only exist if when you plug in a value into the function, you have to have a unique value out. There has to be a well-defined function. So when you plug in the value into the function, you can only have one solution that comes out of the function. Okay, we'll get into that a little bit more of what a function is defined as, possibly a little later. But that's kind of just an idea of what a function, why a function is defined the way it is. So this is not a function. Okay, not a function. Okay, so now I'm gonna, yeah, actually let's just do one more. I'm going to leave. Actually, let's do all of them. Let's just go ahead and do all of them. Let's go into this problem here. So the domain, I'm going to go ahead and let you do the domain and range. Let's just focus on function. So you do the domain and range. It's pretty straightforward. I think we've discussed it enough. But let's just talk about function now. So notice that we have repeating 4s. And we have different outputs. So when we plug in a value of the 4, we have 2 different outputs for that same value that we plugged in. So not function. Okay. So notice here for the fourth problem that we have all different first coordinate values. So it's the function. Notice we have all the same output values. That does not matter. It all depends on what the first coordinate value is. The second coordinate, they can all be the same. No issue. So this is a function. And I'll just mention it right now. The range for this is just simply the value 0, the set 0. All right, let me know if you have any concerns about how to find the domain and range of ordered pairs and how to find if a relation is a function. Okay.